Hi, I'm Akshay. I'm currently a sophomore at Menlo School, but I'm going to talk about a project I made when I was in 8th grade. Now, my project is the Wi-Fi Performance Booster. It's designed to improve the strength of Wi-Fi when you're far away from the router. Now, I thought of this because in 8th grade I did a lot of research on the internet. I used it for all of my school projects. In addition, I also use it for a bunch of other stuff like watching movies. The trouble is that Wi-Fi performance degrades as you move farther from the router. So by the time the Wi-Fi got to my living room, I was getting really slow speeds compared to the speeds I got near the router. So I found that I wasn't the only one having this problem. It's pretty widespread. Basically everyone who has Wi-Fi has this problem. So I wanted to build something that could improve this. The easy solution would have been to buy a new router, but that's expensive and not everyone could afford a new router. So I decided to actually build a device that would improve the strength of Wi-Fi at my iPad or my computer or whatever I was using. So that's where my Wi-Fi Performance Booster came in. The Wi-Fi Performance Booster consists of 3 parts. They each have a different purpose. The first part is the parabolic reflector. This sits on the router. This is a demo router. And it takes signals being transmitted in all directions out of the router and focuses them towards a device or a specific direction. This is visualization of Wi-Fi. So this dot in the center is my router. This is a device of some sort. Conventionally, Wi-Fi would radiate in all directions from the router. So some of it would get to the device, which would be used for whatever the person wants to use it for. But most of it just goes everywhere else where nobody's using it. This is bad because not only do you not get very good strength, but somebody else sitting outside your house could gain access to your Wi-Fi because they're getting an equal amount of signal as you. So, the parabolic reflector sits around the antenna of the router and reflects all of the signals that the router is transmitting towards your device. This means that somebody sitting out here wouldn't get any signals sitting outside your house. So that improves security and it improves the Wi-Fi performance at your device. So this worked, but it would only point my signals in a very specific direction. When I use portable devices, I want to be able to move around and still get Wi-Fi wherever I am. So I thought, if I were doing this to light, and I had a flashlight instead of a router, I would just use a mirror to reflect it where I wanted. So why don't I just do that to radio waves? Just light after all. So I made the mirror deflector. It turns out any sheet of metal will reflect radio waves, just as a proper mirror would to visible light. So by putting the mirror deflector in between the parabolic reflector and my router, Wi-Fi signals will bounce towards my device. Now, this doesn't directly solve the problem of me moving around, so I built a robot to turn the mirror deflector towards wherever I am. The robot is built out of Legos, so it's still fairly cheap. And it simply turns the mirror towards where I am. I wrote an Android app to control this, so I could adjust the Wi-Fi. Now I had solved most of the problem, but the Wi-Fi was still being scattered around my device. For example, if I have an iPad, only part of the Wi-Fi actually gets to the iPad's antenna. Some of it still goes around. So what I would have done with normal light is use a magnifying glass to focus it. I did some calculations and found that if I were to use a glass lens to focus radio waves, the magnifying glass would be about 10 feet in diameter. That was not practical, so I found another technology called a metal plate lens. This uses metal plates, therefore its name, that are cut into this type of shape, and there are multiple metal plates next to each other, each with different diameters where they're cut, and in this case there are 7. They're placed next to each other with a certain spacing in between them. When radio waves pass through this, they get focused towards a certain point, at the same way visible light does with a magnifying glass. Now, metal plate lenses have been used before, but only in the context of transmitting microwaves. I recalculated the diameters and the spacing to allow them to receive radio waves. So the metal plate lens goes in between the mirror and the device, and it focuses the Wi-Fi exactly at the antenna of the device. So, for example, if I were to receive with my iPad here, I would place it behind the iPad so it focuses it at the antenna. So now I have my complete setup. I had my router, which transmitted omnidirectional Wi-Fi, my parabolic reflector, which aimed it in a certain direction, my mirror, which aimed it in the correct direction, and my metal plate lens, which focused it at my device's antenna. All of these parts, excluding the robot, which was built from stuff I had around the house, can be built for $1. So, the parabolic reflector, for example, is a piece of foam covered in aluminum foil with a piece of styrofoam used to get it into a parabolic shape. Styrofoam can commonly be found in packing material. This foam could be replaced by anything. It could be paper. And aluminum foil is a pretty common household material. I actually made some parabolic reflectors in other sizes out of paper. So these could be used on many different routers. The mirror deflector is a piece of cardboard wrapped in aluminum foil. That was enough to reflect the radio waves. And the metal plate lens, aluminum foil for the metal plates, and the stuff in between can be anything non-metal, because any non-metal is transparent to radio waves. So, in this case, I use florist's foam, the stuff used for fake plants. But I also have a version made out of old juice cartons, so it could really be anything. So, I'm really excited that I managed to do all this for under $1, because it means that virtually anyone can use it. This puts the technology that would otherwise cost hundreds of dollars into the reach of billions of people.